Hey students, this is part 2 of Monday's lesson from 111. I wanted to look at the last two problems, and then we're going to look at the homework that was assigned today. So take a look at slide 26. We're talking about Herman and Jaquita, and we're going to use that same idea of guess, check, generalize. So when you look through this piece, what I want you to read through it and then say, hey, what is the question they're trying to ask? So the question that's trying to be asked right in here is, how many months will these two people have the same amount of savings? So we have Herman and we have Jaquita. So let's read through that. We said Herman currently has $15,000 and is working hard to save $1,000 per month. Jaquita only has $12,000 but is saving $1,300 per month. Okay, so one has more money to start with, but one's saving more money each month. And you can kind of imagine hopefully one of them will catch up to the others, right? So let's try to dig into this problem by just guessing. So the first part of guess, check, generalize is to just guess. Guess the answer to this question. I'm going to say, let's try something wild. Like, let's say, 100 months, okay? Guess 100 months. So when we guess 100 months, let's see, what does that mean in this problem? So it says Herman currently has $15,000. So if we guess number one, if we guess his $15,000, how do we find what 100 months does? It says $1,000 per month. So 100 times $1,000 per month. So we're guessing this 100 times 1,000. Okay, so how much does he have? Well, 1,000 times 100 would be 2 zeros, 1, 2, 3. That'd be 1, 2, 3, 4, 5. 5 zeros. That's $100,000 plus the $1,500 that he already had for a total of $115,000. Not bad. If you can save $1,000 for 100 months. Whew. All right. So then Jaquita starts with $12,000. She adds 100 times $1,300. So that's $130,000. 1, 2, 3, 4. 1, 2, 3. Boom. So when we add those together, we get $142,000. Oh, now she has way more than Herman. Okay, so let's keep trying. So that was our first guess. That doesn't work. But again, the guessing's not about getting it right. I'll show you. Let's guess one more time. So guess number 2, let's say something lower. Let's just say 5 months. Okay, so then we have 15,000. How do we find what 5 months does? It's 5 times 1,000. All right, plus 5 times 1,000. And so we get 15,000 plus 5,000. That gives us 20,000. Okay, let me move my face out of the way. If we're doing Jaquita, we'd have 12,000 plus 5 times 1,300. 1,300 times 5 is 0, 0, 5. Carry the 1. 5 times 1 is 5. So we get 6,500 plus 12,000. We have $18,500. Are those the same? No. But hopefully you see the pattern that we just did. So now is the time to generalize. Okay? So let's just take this area right here. And let's say, what if we guessed X months? Herman, right, it would be 15,000 plus X times 1,000. I'm going to just write it 1,000X. Jaquita would be 12,000 plus 1,300 times X. I'm going to just get that out of the way. So 1,300 times X. Okay. So if you can see, We guessed our 5, we guessed 100. Now if we guess X number of months because we don't really know, then we can set this up. And we have 15,000 plus 100X and 12,000 plus 1,300X. We want to know when is that equal. So now we just solve for X. I'm going to subtract 1,000X from both sides. And I get 300X here. That's gone. And I'm going to subtract 12,000 from both sides because I'm going to get all my constants on one side, all my variables on the other. And I get 15 minus 12 is 3. So 15,000 minus 12,000 is 3,000. So I'm left with 3,000 equals 300X. I'm going to rewrite that just so you can see it. 3,000 equals 300X. Divide both sides by 300. 3,000 divided by 300 is 10. So 10 is equal to X. 10 what? In how many months will they have the same? So it's 10 months. So my correct answer is 10 months. They will have the same amount of savings. So that's guess, check, and actually what we did was guess, check, and then we generalized. All right, we're going to try the last problem on slide 27. So go ahead and move to slide 27. And read through that and then come back. All right, so you're reading this. George bought some CDs. He paid $15.95 for each CD. Then Nora bought the same ones online. All right, she paid $13.95, but had to pay $8 for shipping. In the end, they both spent the exact same amount of money. So the question is, how many CDs did George buy? Well, how many CDs did George buy? Well, let's just take some guesses here. If George bought CDs, okay, let's say he bought 10 CDs, how would we find out how much he bought? We would say he paid $15.95 per CD. So $15.95 times 10 would give us $159.50. If he bought 12 CDs, that'd be $15.95 times 12. But if he bought X number of CDs, it'd be $15.95 times. So we can kind of see, like, that's how many CDs that George would buy. Now, if they bought the same number of CDs, what would Nora's equations look like? Well, Nora, if she bought 10 CDs, it would say she would spend $13.95 times 10, right? And what else do we have to do to her? She said she also paid $8 for shipping. So we'd have to add $8 there. And we can figure out that would be $139.50 plus 8 gives us $147.50. That's not the same as George, right? And so our guess of 10 was incorrect. We could guess 12 again. $13.95 times 12 plus 8. I'm not even going to figure that out because what I want you to see is, what we're doing here when we guess, we're replacing the same value. And so when we guess X, Nora's going to pay $13.95 times X plus 8. And so we want to know when those are equal. So we just set up our equation. $15.95 X equals $13.95X plus 8. And now it's a two-step equation, it looks like here, right? We're going to subtract $13.95 from both sides. And 5 minus 5 is 0, 9 minus 9 is 0, 5 minus 3 is 2. So we have $2 times X equals 8. Divide both sides by 2. That gives us 0 or 1, and so we end up with x equals 4. But for what? That's for CDs. All right? So x is the number of CDs they bought. We look here. We look here. Sounds good to me. So that would be another way of using guess, check, generalize. And we kind of sped through that so you could see how that process is working. All right. So your homework for Monday's class is 414, 415, and 416. Let's just take a peek at those questions and see how I can get you started on them. So if you look at 414, it says, a rectangle has a perimeter of 30 inches. Its length is 1 less than 3 times its width. What are the length and width of the rectangle? So we're trying to find what is the length and what is the width of the rectangle. What I would say is, let's guess one of these. Its length is 1 less than 3 times its width. Its length is less than 3 times its width. So length is something to width. So you could guess one of them and go backwards. There's an easier one to guess, but if you try it out a few times, you'll see. Start by guessing its width, right? Because the length is based on the width. So if I guess the width is 10, the length is 1 less than 3 times 10. So 3 times 10 is 30. So it's 3 times 10 minus 1. You can figure that out. Would that give you a perimeter of 30 inches? I can see it's going to be too big because that's 30 minus 1, which is 29. You'd have 29, 29, 10, and 10 if you're going around a rectangle. So that's a guess. Try another guess and see if you can figure out how to use W for width and what you would identify this as for the length. All right. Now, taking a look at problem 15. The coach has this rotation of 5 starting players: Melinda, Samantha, Carly, Allison, and Kendra. However, she needs to substitute Barbara for Allison and Lakeisha for Melinda at this week's game. So what will be the starting roster? You need to rewrite the starting roster, including these substitutions. I think you can handle that one. And then 16, we're trying to correct a problem here. And so what you need to do is look for this problem. The first step here, we're distributing, right? So 5 times 2x, 5 times negative 1. Okay, and then we're combining like terms. So I want you to walk through here and see, where did she make the mistake? Then tell us what will be the correct solution. All right, I can see what it is, and it's going to happen somewhere between these 3 lines. So go for it. As always, bring those questions back to your teachers if you have any issues. Remember, our goal today was to define variables. So like at that last problem, the width, we're going to let the width be W and then find the length off of that. And then we're going to do those and just start solving word problems. So we'll see you tomorrow for some systems of equations and using substitution. Bye.